Hello everyone. What we are going to do is we are going to do a basic data analysis on the dataset which has been provided. So this is the Google Colab on which we are going to do the data analysis. So this is the very basic one. So what I have done initially, I have mounted my Google Drive here, and then I save the data here. So what I did first, I import the Pandas library and I have given the alias as a PD. I can run it. So after running this one, what I have to do, I can copy the path of the data which is on the Google Drive. So we can copy the path from here, we can put it here, and this is the file path. So I am storing the path of the data sheet with the variable name file path. I ran it here, and then I'm going to read. So this is the basically the CSV file. If you'll see it here, has an extension of CSV. So I have to read it through the method read CSV, and I have given the file path here. So it will read the data, and basically data. So from the CSV file, it has been converted into the data frame, and it has been loaded to the data variable here. So now if I will do the data head method, it will give the top 5 records. I can close it here. So it will give the top 5 records from the dataset. Like if we'll see, so this is only for the visualization, and we run it here. Going forward, so if we simply give the data here, so it will give the top 5 and bottom 5 records, and also at the bottom it will say how many row and how many columns do we have into this data frame. And to check the size of a data frame, I can run it here, and we got 569 row and 33 columns. So basically, so I have noted down here into the text field, like we have a data set having the 569 row and 33 columns. So going forward, what I thought to do is like I just wanted to know how many types of data type we have for each column. So this will give us all different type of data types as per the columns. So ID we have a int 64 type, diagnosis column we have as a type of object, and rest of the columns we have as a float 64. So we can call it as a column, or we can also call it as a feature of the data. So here I'm going to find it out how many row we have for each column which has a null value, and I'm adding it. So this is like it will check how many nulls is true, and then it will sum it up. After running this one, we don't have any row having the ID as a 0, diagnosis as a 0, and other value. But if we'll go at the bottom, we have one column which is like there is a 569 entry of the row, and all 569 entries null here. So basically if we'll see, like this data frame has a 569 row, so there is no use of this column, it's redundant and we can get rid of it. So here is the command which I have given, like, so we are going to drop the column name unnamed 32, which is coming up here, and axis 1 is like it's for column, and in place is true, it means it will remove the column from the data frame itself, and it will change into the data frame itself. So we are not going to save into another data frame here. I run it here, and then again I check what is the size of the data frame. So through the save method we can find it out. So here we got 569 row that is intact and 32 columns. So now we don't have the last column, which was nothing but just null entry. Again, I check the data, like top 5 columns, and I, so here if you see, we don't have a column which has a null value. But again, if we want to see the previous one before deleting, if we'll go here on the right, we can see here all the null values for this column. So info method, it's very interesting one. Like it's the very basic information it will give about the columns. If we'll run it, like we got the ID, diagnosis, radius, mean, so it will give us index data type, column data types, none, null value, and memory usage of the data as a whole data frame. So if you'll see it here, we got the memory usage of 142.4 KB around for this data frame. This data is not that much big, but it's good for doing the initial analysis. So here we did the describe, but here we have given the column name, that is the diagnosis, and this will has given us like the five. We have a 569 entry, and we have a two unique value. So we can say it could be the boolean or anything else. But if you see here, like the top value is B, so another value could be anything else. So the frequency is 357. It means B has occurrence of B is 357 times in this data frame. Then I counted, like, so we have only two entries. One is the B, another is the M for the diagnosis column. I counted the value and I save it into the count M variable. So here I have taken the column diagnosis and I am checking the value of the row, whether it's the diagnosis value is M or not. So if it's M, then I'm taking the length. So basically how many entry we have, like how many row we have with the column diagnosis and having the value as a M. So this length will give us the count of row having the column as a M. The same thing I'm doing it here to get for the count for the B value. And at the end, after getting the count value for each type, I'm printing it here. So out of 369, we have a 212 as a M and 357 as a B. The same value we are getting for the 357 as a B here at the, while we have done the diagnosis describe. So it's matching, so it's fine. Then I have done the data describe. So I have not given any column name here, and it will give the like little bit more detail about each numerical features. So if you'll see, we don't have any diagnosis column here. So total column which we have right now here is 31. I can run it. Yes. So this is the count. So basically in this one we got the mean for each core feature, standard deviation, minimum value, 25 percentile, 50 percentile, 75 percentile, and the maximum value. Here also I did the same thing. I have not given the column name here, but what I have, like sometimes if we have a big chunk of data, we don't know how many columns we have as a non-numerical value. So we can directly put it here like the include object or boolean. So it will consider all the columns for which it's going to give the details. So in this case, we have only diagnosis in which we have a count. So we'll get the same result here. So on the big data set, basically we just give the object and boolean so that we can get the details of each columns here, the way we got for the numerical features. Then I counted the mean where the diagnosis value is B and across the data. So this is the mean value of each feature, and again I did the same thing for the aim value, and I found this one. So this could be like we can differentiate based on the mean value for uh, which has a we can find the correlation between the mean and the value of diagnosis, or for the further analysis we'll have to find out the correlation between the diagnosis and the different features. So that could be the next part, but for now this is what I have done for the ICP 01. Thank you.